This is every SAT Desmos hack I know using real College Board questions. I'm Ari. I'm a digital SAT coach. I scored a 1570 on the SAT, and my mission is to help students like you improve on the SAT so that you can have amazing opportunities and joy in your life. The way to get the most out of this video is to like and subscribe. The way to get the most out of this video is to pause the video every time I get to a new question, do it yourself, and then see how I do it. Compare what you do to what I do. Nobody's actually going to do this. Please do this, okay? I promise you, the students that actually do this are the ones with the work ethic to actually make big strides on the SAT. So there's a lot of discussion about, is the SAT becoming Desmos proof? And honestly, I have a lot to say. I could probably do a whole rant video about this question. The answer is no, it can't. Because Desmos is way too powerful. The people who are asking this question, I'm assuming, don't know half of what Desmos is able to do. And that's the only reason they think it's becoming Desmos proof, because maybe the easiest ways of using Desmos are no longer that effective. But there's still a ton of valuable stuff that you could do with Desmos that will make the SAT so much easier. Don't just passively watch this, work with me. Let's go. Problem numero uno, 2 times x minus 5 plus 3 times x minus 5 is equal to 10. What's the value of x minus 5? You could do this with algebra. 2 times a thing plus 3 times a thing is equal to 10. So that means 5 times this thing equals 10. 5 times what is equal to 10? 5 times 2 is equal to 10. This is the same thing as that. So this must be 2. So a is 2. So you could solve this really quickly using some algebra and logic. But we could also use Desmos in a couple of different ways, and I'll show you multiple ways to use Desmos on this problem. And obviously, this is a pretty easy problem, but we're going to use it as a tool just to learn some skills on Desmos. So one thing is, I could just type this thing straight in. 2 times x minus 5 plus 3 times x minus 5 is equal to 10, and it draws a vertical line here. This vertical line's along x equals 7. So what it did was it just solved this equation and said x must be equal to 7. So it graphed x equals 7, which is a vertical line. Okay, and now the question is, what is x minus 5? What is 7 minus 5? That's 2. Okay, that's one way. Another way is using regression. Now, in order to use regression, all you have to do, I'm going to make this bigger. All you have to do is replace the equals with a tilde. That's the sign right above the tab key on your MacBook. If you've got a PC, I've got nothing for you, you loser. We're replacing x. Check out this little thing. X may not be used as a regression parameter. It doesn't recognize x as like a constant that we could solve for. So we have to replace it with something. We could replace it with v, or you could replace it with x1. So if we do v, it solves v is equal to 7. I like x1 because then you'll remember that that's supposed to represent x. So x1 is equal to 7. So what is x minus 5? And you could even type it in, x1 minus 5. It stores the value of x1. So it remembers that it's equal to 7, and it solves x1 minus 5 is equal to 2. And finally, we can break up the two sides and say, okay, we have one side is y equals 2 times x minus 5 plus 3 times x minus 5. And then we also have y equals 10. Zoom out, we see where they cross. The place that they cross is where x is equal to 7. So then again, x minus 5, 7 minus 5. The answer is choice A. And we'll move on to the next one. If f of x equals x plus 7 and g of x equals 7x, what is the value of 4 times f of 2 minus g of 2? This one is so easy, it's crazy. I'm going to type f of x equals x plus 7. G of x, I'm literally just typing in exactly what they have here, 4 times f of 2 minus g of 2 equals 22. That's as easy as it gets. We're literally just taking what's written here and typing it all in, and we get choice C, and that's it. Now, very similar. This one, definitely pause the video and see if you can do this at this point. This is a very easy problem. Y equals 4x plus 1. 4y equals 15x minus 8. I still have students that insist on doing these problems with algebra, and I just don't see why, because it's just too easy to make an algebra mistake. And here, the only mistake you're going to make is typing it in wrong, which is easy to double check. Y equals 4x plus 1, 4y equals 15x minus 8. I see where the lines cross. That's my solution. Where the lines cross is my solution. So the solution, by the way, notice how when you zoom out, these gray dots appear. They appear at solutions and intercepts. Okay, so here's a y-intercept, an x-intercept. If I click on the red line, I get the intercepts. And if I zoom out enough, I could see the solution here at negative 12, negative 47. The question is x minus y. That's going to be negative 12 minus negative 47, and that's 35. Next up, we've got inequalities. Now, Desmos is great at solving inequalities. Here we have y is less than or equal. When I want less than or equal, I just do the less than sign and then the equal sign. And it knows that I mean less than or equal. So just type the less than sign and then equals right after it, and you're good to go. X plus 7. The next one is y is greater than or equal to negative 2x minus 1. Now, we are concerned with the overlapping shaded area. So the purple is everything that satisfies that first inequality. The black is everything that satisfies the second one. And this really dark black purple thing is what satisfies both. And the question is, what point satisfies both? Is a solution to both. So it has to live inside this super dark area. Now, you could probably visually just figure out what the answer is, but if you want to be sure that the answer is 14 comma 0, which is definitely the answer, you could actually plot 14 comma 0 like this. And there it is in red. So we could see that it's comfortably in the dark zone. And by the way, if we look at a different point like A, negative 14 comma 0, that is outside of both regions. So that's clearly not the answer. So the answer is choice D. Next up, we've got equivalent expressions. Okay, this one, equivalent expressions are probably like the simplest, or like they're the most formulaic things to solve using Desmos because all of them basically work the same way. I realize my face is covering too much here. Let's move me over here for now. Okay. Hopefully that wasn't affecting other problems because I was not paying attention. Okay. I'm going to type in this first expression, and then I'm going to graph all the other ones and see which one overlaps with the first one. Now, here, it wasn't graphing it until I put y equals. Let's see what it says. Try adding an equal sign to turn this into an equation. Okay, that's fine. We could just type y equals this, and we'll do the same thing with the other ones. I don't think that'll cause any issues. So this red graph here is what we're trying to match. So let's look at the other ones. Oh, by the way, one thing to note is there's a square root and nth root function that are really helpful to know. So if you just type sqrt, you get the square root symbol. If you type nthroot, nth root, you can customize what root it is. So if you have something to the third root or fifth root, sorry about the UI, it gets cut off a little bit. I just typed the number 5 here. You get the fifth root of x. So those are very useful keyboard shortcuts, but you don't need to memorize them because you can find anything you need here. So if you're looking for square root or nth root, you could also find it right over here. So you don't need to memorize that, but it's helpful. So clearly choice A is wrong because this looks nothing like the red line. But what if I turn it into choice B? That's y times the square root of y. Nope, that still doesn't work. Notice I just made this into choice B. Choice C, we have to make this x, and we have to make this square root of x. That one also doesn't work, so hopefully D is going to work, because otherwise we have no correct answers. And yeah, choice D works beautifully. Notice how if I unclick it, I get the red line. If I click it, I get the purple line. They overlap completely, so choice D is going to be my answer. Now, every single equivalent expression problem, almost every single one, works the same exact way. You might have to turn things like a and b into x and y in order to actually graph it on Desmos, but conceptually, they all work the same way. Okay, now we have a different type of problem. These ones get a little bit more complex, but we see that we have a table here, and it says the table shows two values of x and their corresponding values of y. So this is basically like a function. The graph of the linear equation, okay, so we know that this is representing a line. That's helpful. It passes through this point. What is the value of a? So I'm going to go here and click the table button, and I'm going to add a table and type in the values. Negative 48, and then we have 7 and 52. And this button right here is add regression. I'm going to add regression and make sure that it's linear. Why? Because it says that it's a linear equation. Okay, so I'm not going to turn this into a quadratic regression. I'm going to keep it linear, and it tells me that it's 4x plus 24. Now, from here, there's a couple ways of solving it. We have a point at 1/7 comma a. So we know that the 1 over 7 is the x value, so we could just type 4 times 1 over 7 plus 24, and this is my answer. Now, a little trick, since none of these answer choices actually match, I could click this fraction button. It turns it into a fraction, 172 over 7. That's choice D. I've been noticing we're always getting choice D. Maybe all of the answers are choice D. Okay, so that's going to be the answer. One other way I want to show you is we could type x equals 1 over 7. That just graphed a vertical line where x is equal to 1 over 7. And you'll see where they cross is that point, that 24.57 thing. And this is probably a little bit hairier, but I could just paste that in here for a second. And then I could look at each of the answer choices and evaluate them. Like C is 4 over 7. So I type in 4 over 7. I see that's 0.57. That's nowhere near my actual answer of 24.57. Then if I look at choice D, 172 over 7. Oh, that matches. Okay, so that's definitely going to be the answer. Okay, take a moment, pause, and see if you could solve this one using a similar technique to what we just used. Okay, we're back now. So Hector used a tool called an auger to remove corn from a storage bin at a constant rate. Constant rate, linear, okay? He's always doing the same amount. Every hour, he's removing the same amount from the storage bin. A bin contained 24,000 bushels when Hector began to use the auger. Okay, beginning, that's like when time is at 0. After 5 hours, he had 19,350 bushels of corn remaining. Okay, so I want to add a table. I'm noticing they're like kind of covertly giving us a couple of points. So when time is 0, he's got 24,000 bushels. And when time is at 5 hours, he's got 19,350. Now, I could do the same thing. Linear regression. This is my function. So the question is, at what total number of hours will he have been using the auger when there's 12,840 bushels of corn remaining in the bin? Now, notice the 12,840 represents the y value, not the x value. So we want to say negative, or I could probably even just copy and paste this. And we're replacing y with 12,840, and it'll graph it. I might have to zoom out a lot. Okay, here it is. At looks like 12. X is equal to 12. So D is going to be my answer. Alrighty, now we've got some non-linear functions. Let's take a look at how we can do this. Again, I'm just going to type this straight in. Negative x squared plus bx minus, I keep doing that, negative x squared plus bx minus 676 equals 0. Now, this is going to create a lot of issues because we have a b here that's not supported. So the way we could deal with this is if we type b equals like anything 5, it creates a slider where we could adjust what b is. Now, visually, I'm not seeing anything. And there's a good reason for that, because I don't know what's going to trigger this function to actually have solutions, meaning I don't know when this thing is actually going to ever equal 0. it might be really negative right now, and that's why I'm not seeing any solutions. Now, a way to remedy this is to make this into two different graphs. So I'm getting rid of that, and I'm typing y equals 0. And now if I zoom out, oh, there it is. Okay, this is my function. I need this thing to equal 0. I need it to rise up from the ashes and hit this line over here. The question is, in the given equation, b is a positive integer and the equation has no real solution. What is the greatest possible value of b? So basically, I want to make b bigger and bigger until it gets really close to having a solution but doesn't have a solution. How big can I make b? And as I drag it to the right, it's starting to rise, okay? Now, I want to make it even further to the right, so I'm going to make the upper bound 100. And I'm just going to keep dragging. Oh, now I'm crossing it. So now I need to zoom in and get a little more precise. I'm at b equals 52 right now, and it looks like it's touching right here. So let's go back to 51, and here I'm good. So that's the highest integer. Notice integer means that it's a whole number. So b is going to be equal to 51. So this is using a slider for a constant and comparing two different functions, basically y equals 0 and this function over here. Okie doke. For the exponential function f, the value f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? I've seen a lot of students stumble on this problem and problems like this. So let's actually just look at the first answer and try to understand what's going on. So this is f of x is equal to 50 times 2 to the power of x plus 1. Notice whenever you have like a complicated exponent, you typically need to put it in parentheses, because if you don't, it'll just like move down automatically. So always put it in parentheses. That's an easy thing to mess up. Now, f of 1, they said is equal to k. So f of 1 here is 200. Do we see 200 as the coefficient or the base of f of x? No. The coefficient's 50. The base is 2. Neither of those numbers are 200, so A is out. Now, if we look at choice B, we make this x and we make this 80. Notice f of 1 automatically updates. It automatically sees what the new function is and says, okay, let's evaluate this one, x is equal to 1. This is 160. Again, we don't see the number 160 here or here, so this is not correct. Now let's try C. That's 128. And we have to make this x minus 1. And here we're good. Okay, so f of 1 is equal to 128. That's k. And we see k, or 128, right here. So C is going to be the right answer. Okay, this is not exactly a Desmos type of problem, according to most people, but I think this is where people are missing that actually like a ton of problems can be solved using Desmos, even area and volume problems, which we don't typically think of as Desmos type of problems. But here we go. A cube has a surface area of 54 square meters. Okay, so surface area is like adding up all of the surfaces. And a cube has 6 surfaces, and each one of them is side squared. Okay, so 6 times each side squared gives me the surface area. So if I want to figure out a side, I could set this equal to 54, and it tells me S, the side, is equal to 3. Hopefully that made sense. I'm just using the surface area formula and basically setting it equal to 54 because they tell me that it's equal to 54. But instead of just writing equals, I'm using regression to actually store the value. I'm solving for S. The side is 3. Now, what is the volume? If I know the volume formula, that's just side cubed. S cubed, 27. So in 2 quick steps, I'm able to solve this area and volume problem that at least the College Board thinks is a difficult problem. Now, if you do this in a classroom, the teacher will usually say something like, use completing the square, which is not a very hard technique, but it takes a lot more time than just graphing and eyeballing the center, honestly. Like, it looks like the center is around -10, -8, or something like that. And yeah, that's an answer choice. So B is probably the right answer. In order to like confirm, you could just plot it, -10 comma -8. Here, none of the answer choices are like super close to each other, so you don't have to be super precise. If you want, you could plot all four answers and it'll be very, very obvious that B is the right answer. Okay, what is the value of sine 42 pi? This is really, really simple. I just wanted to show you one thing that's really important to note when you're dealing with things like pi and sine and cosine. You need to make sure you understand whether you are in radians or degrees. So when we're dealing with things like pi, we want to be in radians. If you click this wrench in the top right corner, it opens up settings. Most of these you're never going to have to deal with, but radians and degrees you do have to deal with. Let's just see what happens if I'm in degrees. It's not going to give me the right answer. Sine of 42 pi. If I type the letters pi, I get the pi. Okay, so this gives me this big mess. 0.7437. The only answer choice that might be right is rad 2 over 2. Square root of 2 divided by 2. And even that is wrong. So none of the answers are 0.7437, whatever. Now, if I switch this to radians, oh, now I get 0. And 0 is choice A. So now I'm good to go. But keep in mind, whenever you're dealing with problems like this, you need to make sure that you know if you're in radians or degrees. This is how you do it. That was the main reason I wanted to show you this problem. X squared plus 14x plus y squared. This looks like a circle. Okay, in the xy plane, the graph of the given equation is a circle. What's the length of the radius? Again, we're just going to graph it. So I'm just literally going to type it in exactly as it's written. 14x plus y squared equals 6y plus 109. Okay, here it is. By the way, if you click on the circle, it'll highlight a few points. It's highlighting x-intercepts here and here, y-intercepts here and here, and the top and bottom. Okay, this is the highest point on the circle. This is the lowest point on the circle. Okay, if you ever have a parabola and you need to find the vertex, just click on it. It'll show you top point, bottom point. When I talk about the parabola example, I mean like x squared plus 7. Okay, maybe I'll even make this a little more complicated. Make this like x minus 2 squared plus 7. The vertex is right here at 2 comma 7. So that's a really easy way to find the minimum or maximum of a parabola or any type of function. Okay, here, the top point is 15.923. So I'm going to copy that. And the bottom point is negative 9.923. So the difference between them is going to be the diameter. Half of that is the radius. So the radius is about this. Again, it might be doing a little bit of rounding here, I'm not sure. But if I type in the answer choices, one of them should be really, really close. So let's just try them. Square root of 109, that's too low. Square root of 149, that looks close, but no cigar. 12.2 and 12.9, that's a little too far off to just be a rounding error. 167, that's more like it. See, this rounds to 12.923. So square root of 167 is going to be the answer. All right, now we're up to percentage problems. Okay, the number A is 190% greater than the number B. The number B is 80% less than 24. What is the value of A? Okay, so if A is 190% greater than B, so A could be equal to, keep in mind, 190% greater than B. It's not 190% of B. It's 190% more. So B is already itself, it's already like 1 of B, and then 190% more than that, you're going to end up with 290% of B. So you could either do 2.9B, or I'll show you a cool function, 290% of B. If I type in the percent key, it automatically gives me the word of, and then I could type my next value. Now, so far this makes no sense because I have no idea what A and B are, but we're going to get there. Okay, the number B is 80% less than 24. So that's basically 20% of 24. 80% less than something will end up being 20% of that thing. And it solves for both of them. A is 13.92, B is 4.8. So this one asks me for A, so choice B, which is confusing. Choice B is the answer. Next up, a gift shop buys souvenirs at a wholesale price of $7 each and resells them at a retail price that's 290% of the wholesale price. So let's use labels. So the W is for wholesale, okay, at $7. So let's just say W is 7 each and resells them each at a retail price. So R is going to be retail price equals 290% of. So here we could just go 290% of W. So the retail price or the retail price is going to be $20.30. What else? At the end of the season, any remaining souvenirs are marked at a discount price that is 80% off of the retail price. So D is for discount price. That's 80% off. So that's going to be 20% of R. What is the discounted price of each remaining souvenir in dollars? That's going to be $4.06. 4.06. Cool. And let's just see. There might be a way to do this with regression. If we do, I want to show you guys multiple regression. So if I do W tilde 7, I want to kind of stack formulas here. So I'm going to do a comma. So W is equal to 7. So W tilde 7, but I want to give regression all three of these formulas. So I want to show you how to do that in one line. This is really, really cool. R is equal to 290% of W, and D, so notice I'm doing the left side all on one side and the right side's all on the other side, and they're separated by commas. So this is not 7,290. This is 7 is W, 290% of W is R, and D is going to be 20% of R. And now the only reason it's not working right now, I believe, is because they need to be in brackets. So if we bracket the whole left side and then we bracket the whole right side, it should solve for everything. Now let's just get rid of all these. There we go. W is 7, which it got from the first equation. It solved R from the second equation, and then it solved D from the third equation, and it gave me the correct answer of 4.06. So this is a really, really cool pattern that when you're given multiple equations, or you're given the ability to derive multiple equations, you can typically put them in a regression grouped up as question, answer, question, answer, question, answer. Hopefully that's helpful. By the way, all of this practice that I'm doing is on Pattern SAT, which is a platform that I created to help students like you excel at the SAT. And specifically, it helps you find the types of wrong answers that you consistently fall for. So if you're making mistakes and you're kind of stagnating around 11, 12, 1300, this is honestly a great place to practice. It's completely free, so there's like absolutely no strings attached. And yeah, I hope you find it useful if you're looking for a place to practice problems. Here we go with one more. In a sample, 80% of the items are faulty. There are 88 faulty items in the sample. How many total items are in the sample? This is really, really simple. And a lot of people get tripped up on it, but 80% of the items are faulty and there's 88 faulty items. So this is really simple. 80% of the items. Okay, we're trying to find how many total items there are. So 80% of items, let's call it T, or let's call it V, is 88. Sorry. So the number of items is 110. 80% of some number is 88. That number must be 110. By the way, you could also do this with graphing. 80% of x equals 88. If we zoom out enough, we should see 110 right here. This is graphed along 110, so that's going to be my answer. All right, hopefully you found this stuff super, super helpful. Remember to like and subscribe. I'm going to be posting a lot more SAT content. And check out Pattern SAT, check out my website. If you're looking for private tutoring, I'll leave my contact in the description. And I sincerely want to wish you the best of luck while studying, and you're going to do great.